Hello students. So let's try to solve one very beautiful problem from JEST 2021 examination. And this is from the part B. And I think this is question number 13 for set D. And it is a quantum mechanics question. So it's a wonderful question for a conceptual point of view. So what is this problem? A particle is confined in a box and the length of box is given by 0 to L. And we have to calculate what will be probability such that particle will be between 0 to L by 3 for the state where n tends to infinity. So it's a wonderful problem. So if I am talking about n tends to infinity, means I am talking about in a very higher state. You can have infinite number of state possible because the particle is trapped for any value of energy. The wall is rigid. Now, what is the idea behind that? If you are talking about infinite, very large value of n, that means if I am talking about n tends to infinite, means I am talking about very large value of n, then we have a probability density something like this. Something like this. Isn't it? Something like this. And it's also a observation that when you have at a very higher state, then the quantum property of a particle is not predominant, and there the classical property of a particle is dominant. So at the higher level, higher state, energy state, basically energy state, that means when n tends to infinity, classical behavior is dominated. Now, what is classical behavior? If your particle is free inside this box, means every distance is equal probable. This is the beautiful part. So if every distance or every point is equal probable, means we can have a wave function, which wave function is nothing but constant between x is between 0 to L. So we can assume that my probability is constant. And you can say if we have n number of things, then this is almost constant. The probability density is almost constant. Every point is equally probable. So we have to calculate the probability between 0 to L by 3. We can have some a value. So we can calculate probability between x to L by 3 is equal to integration of mod psi squared dx 0 to L by 3, and obviously we can go for mod psi squared dx 0 to L, and this value is, you can just go for mod a squared dx 0 to L by 3, and you have basically mod a squared dx 0 to L, and this value is calculated, and when a square will be calculated is cancel out, and this value probability such that x is between 0 to L by 3 is nothing but 1 by 3. And also you can do it in a very nice way. Suppose if my probability density is constant, so if we have constant probability density, then the area under the curve is the probability. So suppose this will be L by 3, this is 0, this is L. So area under this curve is equal to 1 by 3 with respect to 1. If total area is 1, then obviously up to this, the area will be 1 by 3. So we can easily calculate this particular thing. So this will be 1 by 3 will be answer. And it's a wonderful question because we have to understand that as our n is increasing, not only in particle in box, but in general, in every system, every bounded system, you can see that higher value of n, the classical picture will predominate it. Thank you.